Okay, can you hear me?
Yes, yeah.
Right, okay. What I've done is, hope you can all hear me nice and clearly. I actually started two talks simultaneously, and I think the two parts of my talk fit together. There is a connection, I can see it, and we'll explain it later on. But I've been going out over the winter months, and Auriga, the constellation, I thought, well, as it's normal for me to see Capella first, even when it's cloudy, if there's a slight break in the clouds, Capella's overhead. So usually that's the first star that I've seen. So I thought I'll give a talk about Auriga and Capella. Okay, and that shows it there. And it shows the 8 main stars, which I'm going to say a little bit about in a minute. And the one that actually joins on to Taurus, which is now called Beta Tauri, was originally part of the constellation of Auriga, and now it's regarded as part of the constellation of Taurus. But to make that shape up perhaps a little bit, you still see it seen sometimes as being part of the constellation of Auriga. Hang on. I do a lot of naked eye observing, so-called, and I think, to be truthful, I actually do more seeing than observing. So I thought I'd put that quote from my hero, Sherlock Holmes, speaking to Dr. Watson. He says, "You see, Watson, but you do not observe." And I'm going to give an example in a minute of something I've been looking at for ages and haven't actually noticed what I've been looking at. It's spring at the moment, loads of daffodils, ever so nice. And I found this lovely quote, which is slightly inaccurate, but I thought I'd just share it with you. "March begins with the blare of heaven's trumpets. Wind stirred into life by the radiant warmth of the young sun lashes the budding trees. As if in keeping with March's martial airs, the night sky announces Auriga, the charioteer. Auriga clatters across the northern skies behind a team of goats led by Capella, a bright star thought by the Greeks to be someone called Amalthea, who was the young she-goat who suckled Zeus as a baby." And of course, as everybody knows, and Patrick Moore points out, Auriga is actually a winter star. It's been around since autumn last year. It's not sort of suddenly appears in March, and it hasn't been there before, but apparently the best time to see it is late February and early March. That's a picture of the constellation. You can see that it's made up mainly of 8 stars, but the bottom left-hand one, which I'm going to say a bit more about in a minute, is actually now counted as being part of the constellation of Taurus, the bull. I didn't realize until recently the reason why Taurus, the bull, you only see the top half of it, you don't see the body or the legs or whatever, is because when Zeus, the chief of the gods, decided to appear to a maiden and try and seduce her, he disguised himself as a bull, but he was standing in the water. So only the bit above the waist, if you like, could be actually seen. That's why Taurus, in a way, is half a constellation. Okay, a constellation. I thought you'd like this nice picture of Patrick Moore. I hope you can all see it. He points out something that's really obvious. A constellation has no real meaning, as the stars are not at equal distances from the Earth. From a different vantage point in the universe, the constellation patterns would look quite different. Okay, the man on the right is actually looking at Auriga, but you'd probably find it very, very difficult to make it out at all. It is there, but I can't see it that clearly. And when I go out to my daily walks to Walton Hall near where I live, where I was there about an hour ago, I can't see anything like that number of stars, okay? But I can certainly see Auriga because it's overhead. It's near the zenith, i.e. 90 degrees straight above you. And at one point, about a month or two ago, Capella was magically right above me. I don't know how God managed to manage that, but and then it moves, of course, and that shows 2 of the 2 Messier objects, which I'll mention in a minute. That's what you actually see when you're outside. As I say, again, excuse me, I don't see all those stars, but I can certainly see the constellation. That's the 8 main stars, with Capella as the main one. And they've all got sort of funny names. Some of them are Arabic, Almaz, El Nath, and I'm not sure the languages for the other ones. And the three that I'm going to talk about in particular are Capella, El Nath, and Almaz. First of all, El Nath. I've already said that that one is now regarded as being part of Taurus the bull, which it shows you there. In fact, the top of one of the horns of the bull. And there you are, nicely labelled. You know, I've been out that many times and I've never seen those signs in red up in the sky. I have looked really hard, but I've never managed to actually find them, nor the lines joining all the constellations together either, but never mind. Right, that's an artistic representation of this character who was a charioteer. He's normally shown with some reins in his hand. Sometimes it's a whip, and for some strange reason carrying a goat and 2 or sometimes 3 baby goats. That's another picture. His name in Greek, it's a character called Eric Thonius, among other names. I've seen it, just call him Eric, but he's also got another name as well, which I think is Myrtulis, if I remember rightly. Eric Thonius was actually the son of Vulcan. I think it was the fire god Vulcan, if I remember rightly. And he was born crippled. He had a problem with his leg, and so he invented the 4-horse chariot, which is known as a quadriga, so he could go anywhere he wanted in the heavens. Right, Capella, the main star. Capella is actually, it's not just a binary, it's actually a quadruple star. The word itself, Capella, means a small female goat in Latin. It's one of 7 stars with known planets. There are actually within the boundaries, or within the area that is the constellation of Auriga, 65 stars altogether, but it's the main 7 or 8 that form up the pattern. I should have said, by the way, because I'm talking quickly because I'm aware of the time, that Patrick Moore describes it as the shape of a kite. And just to show my ignorance, I thought, it doesn't look anything like a bird. I was thinking of a red kite. No, it means a kite that you go out with, or you could also say it's the shape of a pentagon. It's a conspicuous yellow giant. It's 42.9 light years away, and it's very interesting. The reason I was going to put something in there because I've been looking at it for ages, and only recently when I read it was yellow, golden yellow, that I realized it is golden yellow, but I'd never really noticed that. So if you think of the comment I made at the beginning, you see but you do not observe. I sometimes look at things and I have to be told things before I actually observe them properly. It's the 6th brightest star in the night sky and the 3rd brightest in the northern celestial hemisphere. Just to show my appalling ignorance again, which for somebody, I've been a member of the Leeds AS since 2004. I hate to admit it, but I was thinking, hang on a minute, Arcturus, Vega and Sirius are all brighter than Capella, but of course Sirius, the number 1, although it appears in the northern celestial hemisphere, is actually counted as a southern celestial hemisphere star. So it is the 3rd brightest in the northern celestial hemisphere. It's actually a quadruple star system. In 1899 at Lick Observatory in America, William Wallace Campbell discovered it was a binary. Okay, it's not an eclipsing binary like some binaries are, but it is a binary system. And sometimes you'll hear the main 2 stars in Capella described as A and B, but strictly speaking, it's actually A small a and A small b. And sometime later, I've put in 1936, it was actually slightly before then, but it was finally decided in 1936. There were 2 smaller ones called H and L. And I wondered, why is it, where have, you know, B, C, D, E, all the others gone? No, those stars do exist, but they're not regarded as being part of Capella. So AA and AB have an orbital period of 104 days, 104 days going round each other. Just of interest to anybody that is interested, Capella actually was mentioned in a Star Trek episode in 1967 called Friday's Child, where there was a planet called Capella 4, and Dr. McCoy said that he'd lived there, although he hadn't been very happy living there. Okay, with that picture there, they do call them A and B, but as I say, bear in mind it's not A and B, it's A small a and A small b. Then you've got Capella H, Capella L, and then you've got the sun for comparison. So having sorted out where C, D, E, F and all the others had gone, you can imagine I was a little bit confused, so that's why I put that picture in there. That gives you some idea of the distance from each other, but obviously looking at it from the Earth, it just appears as one big star, Capella. You've got 3 Messier objects in the constellation: M36, which has got about 60 stars in it; M37, have I just missed something? Oh, sorry, M36, I've got to say the pinwheel open cluster of stars. You've got the M37 open cluster, which is described as the best of the lot, and there's over 500 stars in there, and M38, which is the starfish cluster, and there's about 100 stars in there. You can't see it that closely, but you can see it if you've got good eyesight. The 3 main stars in it, actually, I'll let you do it in your own time because I need to finish this first half of my talk before we go outside, actually forms the letter pi, the Greek letter pi. There's also IC405, the Flaming Star Nebula, and very, very quickly, Epsilon Aurigae. Each of the stars in a constellation has a Greek letter, so the 5th Greek letter is Epsilon. So Epsilon Aurigae there, also called Al-Ants or Al-Mars, the billy goat, that's an eclipsing binary, and the 2 stars, one's a star, the other's like a disc-shaped thing, very strange. Takes 27 years to go around each other, which is the longest period of time for any binary system that we know of. It's also the most distant of the brightest naked eye stars, and it's approximately 1,350 light years away. When I looked that up today, and last slide before we go outside, the first one I looked in said 7,000 light years. The second one I looked at said 6,000 light years. Patrick Moore says 3,600 light years. So I think, okay, I'll just call it at least 1,350 light years, plus or minus 300 light years either way. I thought just to finish off the first part of my talk, I'll just sort of say, show you pi, which is a very big number. And I'll just have me saying there, it's a BBN, which is an astronomical term, and it means a bloody big number. Okay. Patrick Moore finally says that a million's a hard concept to take in. So when you're talking numbers that go into this number of decimal points or 1,000 light years, light takes 6 trillion years in a year to travel. So you've got to multiply that by so many thousand. It's a hell of a big number. And what I'll do is I'll finish there at exactly 1 minute to 8. And if it's all right with you, Rod, I'll do the second part of the talk after we come back. Is that all right? Right. The second part of my talk is quite different, but before I just go on to it, I forgot to mention, because I was rushing, because I had trouble starting. So because I was rushing, I forgot to mention about Epsilon Aurigae. I sent an email to Ray Emery yesterday because it's definitely 27 years. I've checked it in about 6, 7, 8 books. And Patrick Moore, in his 1988 Observer's Book of Astronomy, has actually managed to bump it up to 127 years. I wonder if that was just a proofreading error or what it was, but I thought I read it, I reread it, and he definitely puts it as 127. No, it's not. It's definitely 27. So I won't blame that on Patrick. It's probably, as I say, I think it's a proofreading error when the book came out, somebody didn't check it properly. Okay. Right. Okay. And I forgot to mention as well, by the way, Capella, the main star, is strong source of X-rays. Those people who might be doing pub quizzes in the future. Not that they're likely to be asked that, but anyway, I thought you'd like to know it. Okay. I go out and do naked eye observing, as I said, and most days I go to Walton Hall. So I thought I'd second half of my talk, I'd talk about Walton Hall sundial, which is a very spectacular sundial, and just tell you a little bit about it and show you some pictures of it. This is Walton Hall. It's actually, when it was first put there, 1767. A few years later, the owner of it, the last but one owner, Charles Waterston, was born in 1782, and he made it into a nature reserve. It's actually a golf course as well now, but it's been designated as a World Heritage Site. It stands on an island. The sundial I'm going to talk about is at the top left of the house, behind that chimney, just behind that. Okay. Here's a picture of it now, and it's a hotel. It's a setting for weddings, and although she's not here now, Maggie, my wife, was born there in 1955 because after the Second World War, it was briefly a maternity hospital. Nothing to do with astronomy, but they had to get a nurse to carry the newborn babies across that bridge because a young mother on one occasion threw her baby into the water. So to make sure that didn't happen again, the nurse would have to carry the baby across safely to the car park. And yours truly, I've fallen in that lake as well when I was taking part in a canoe race a few years ago. Right, very quickly, I'm just going to set the scene, because if you don't know about Charles Waterston, you won't understand about the sundial. Charles Waterston was a very famous naturalist, and picture of him there, a little bit strange, very well travelled. He's regarded as the founder of modern taxidermy, and the originator of nature sanctuaries. And as I've said, Walton Hall is regarded as the world's first official nature sanctuary. As well as stuffing animals, he used to make these monsters like the one on the right there. This man used to visit him quite regularly. Charles Darwin first came to Walton Hall in 1845, and I think it's ironic that in 1845 nobody had heard of Charles Darwin, whereas Charles Waterston was very famous, whereas nowadays most people, if you mention him, don't know who Charles Waterston was, but they know who Charles Darwin was. That's Waterston Park Lake in Canada. I've only put that in because I've swum in the lake, I've been there, okay, and that was named after Charles Waterston. Just quickly, before I go on to the sundial, he was a great animal protector, but when he killed animals, he could be quite ruthless, and that's where he's riding on the back of a caiman. Poor old caiman has a hook in its mouth and people holding on to him and doesn't stand much chance. And that is now in Wakefield Museum. My grandchildren love to go and have a look at it, and it's there with a load of other things that Charles Waterston collected. That's a bird hide which is 200 years old this year, and that's the big wall that was built around the estate. And just last of all, I'll quickly tell you that he liked certain animals, he didn't like others, so he made sure every brown rat was killed off, and I don't think he liked stoats or weasels, but everything else was welcome. That's his grave. You can see the inscription in Latin, very devout Catholic. That's his funeral party, and you can go and visit his grave, which is on the estate. That's one of his biggest fans, Sir David Attenborough, who opened up the Charles Waterston exhibition at Wakefield Museum a few years ago. Okay, the sundial. That's a picture of it. It seems to have moved a few times over its lifetime. At the present moment, it's actually facing the lake, which means it's facing south. We've got north behind us. That's another picture of it there. You can see it's a little bit run down. It's not in a great condition. And that's an early picture of it where it was in its prime, looking really well. You can read the writing and the numbers and whatever on it. And that's a lovely picture, a drawing that was in a book in 1935. Right, most sundials tell you time in one place, and so you need a lot of them to find your way, time in different parts of the world. The one at Walton Hall is actually designed to tell the time simultaneously, well, simultaneously in different places in the world. It's made of ashlar, which I think the actual stone is sandstone. Ashlar is a name for large, regular, squared stone blocks. The gnomons are made out of copper. It's in the shape of a polyhedron, 20 equilateral triangles, and it shows the solar time in Amsterdam, Bâle, Boston, Demerara, Madras, Madrid, Mexico, Moscow, Beijing, Philadelphia, Rome, and Warsaw, which I'm assured are all places that Charles Waterton visited in his life. And it actually shows the order of longitude for each of those places. Okay, I won't try and explain. I'll leave it to the more expert explanation of Dave Sellers if you want to know how to find ordinary time from solar time. But solar time means time measured by the sun passing over overhead. George Bulby, who made it, he was totally uneducated, but managed to scrape up enough money to buy some books by Plato. He's described as a common mason. I looked up the British Sundial Society list of famous sundial makers, and he's not even mentioned, which is a shame because he actually did quite a few sundials, but possibly because he was from up north in Yorkshire, he doesn't deserve a mention. And I've looked at some other books that I've got on sundials. Probably David Sellers say he has got books with him mentioning, but I've got a book down here on sundials. Again, it doesn't mention him. He was born in Crofton, which is the next village to where I live. And just before I show you a bit more of the detail of the sundial, Charles Waterton paid 20 guineas for it, a lot more than it was actually worth. But Charles Waterton was a very generous man, and he felt that the man who made it should be properly remunerated. So he paid him the grand sum of 20 guineas, which is quite considerable. I put that in because on the thing it says George Bulby Feckit. It's not Father Jack from Father Ted saying Feckit, Feckit. It's Latin for he made it. Okay, so on each of his sundials it will have his name carved on it, the word Feckit, and the year it was made, which the one here at Walton Hall was made in 1813. That's showing you the capital on top of the column, which supports the sundial, and it shows you the 4 points of the compass and all the other points of the compass as well. Interestingly enough, by the way, I can't find any record that, apart from having the sundial, that Charles Waterton was interested in astronomy. But as he did extensive explorations in South America and elsewhere, I would assume that he knew how to navigate using the stars, because he was a very clever man, an educated man, and I assume that he knew enough astronomy to actually find his way around, even if he wasn't interested in astronomy per se. That's another one shows there, and if you've got keen eyesight, you can see it shows you the time in Amsterdam, Rome, Warsaw, Moscow, and also this one shows the river Orinoco. You'll notice the person who wrote it has put sundial twice, sundial, sundial. But as I say, don't ask me to explain how it works. That's another picture of it, and I'm a bit puzzled. The one on the left-hand side is cigarette card advertising Fry's chocolate. I don't know what the connection between the sundial and Fry's chocolate is. And the one picture on the right confuses me just a little bit, because if you look at all the other pictures, and I'm sure David or somebody else will explain it to me, on all the other pictures, the gnomons are going at an angle, presumably the Earth's axis. I can't understand why in that picture they're pointing upwards. I've never seen them point upwards, and I go there, and Maggie and I sit there and have afternoon tea and sit next to the sundial, and I can assure you that they aren't pointing upwards at all. So I cannot understand with that one why the gnomons are shown pointing upwards. Just briefly to finish off, another sundial of George Bulby is at Rugby Church, the church just next to Nossal Priory. On the south door, you can see it there above the door. If you ever get a chance to go and see that church, by the way, It has some very interesting stained glass windows that you won't see anywhere, the like of them anywhere else in the world. They came from Switzerland in the 1890s, and each of those little round circles tells a little story from the Bible. Okay, that's a close-up picture of it. You can see his name there, George Bulby. And he also, I found another picture of this church, which is at St Richard's Church at Aberford. Tells you that it was put there in 1806, Anno Domini 1806, George Bulby, Fecit. Okay, I thought just to finish off, I was going to give you an inscription from a sundial. I couldn't find one, so I thought this was a nice little thing to, just before we finish. Hide not your talents, they for use were made. What's a sundial in the shade? It's a saying of Benjamin Franklin. I hope you see there is a connection. The connection I tried to make is that I look at Auriga from Walton Hall, so I thought I should talk about the sundial. And also, sundial is a man-made instrument for telling the time, and a constellation is an imaginary invention to make sense of the stars, because obviously the constellations are not there. It's only our perception of them that puts them there. So to finish off, I'll leave you with this saying of Nicholas Parsons: don't count every second, make every second count. And I hope you've enjoyed the talk, and I hope it appears that the whole talk hangs together. Okay, thank you very much.